Hello everyone. Video ahi moment of inertia part 2 ibolde hinden lecture ma sajo part 1 ibolde ta na tilai jo moment of inertia system of particles sajong chule rigid bodies are theorem ni jong simo chuna. So you have to study those things betang NCERT textbook ajong ho chi perpendicular to parallel axis theorem pa he na chiten hi ki remove ai ta na tha pa ho e wanga chu it is still important, okay? Moment of inertia hold on na head team ngai cho as a question to a hit video here radius of gyration involved use na chila so in fact ke du cho apoi modan chana. Okay, so we'll continue masapena chu radius of gyration chu pi ke sai na ha definition cha chu poi mo lo na e wang chu radius of gyration inti ke hol ham a hol nan pa cho poi mo cho si. So here are just for basic understanding na tempat knowledge na anything wa chu chala definition dan you can see then radius of gyration chu piham tele. So this is a concept used to describe the distribution of object's mass. Okay, so how the mass of the object is distributed around the axis of rotation. Na bailam ta ti ha simple ta se dinga chu piham tele. It basically represents an average distance from the axis of rotation at which the mass of object can be thought to be concentrated without changing the object's moment of inertia. Suppose I have a rigid body rigid body khari ale hin chi rigid body pa hi chelai axis ahi ki rotate cho na chelai axis ai ki rotate in le chu see you can think of this as you can assume this rigid body as a point mass m na chu hila axis of rotation apala hi k distance ai gam ha cho hi pa hi tai kivial kol na si point mass pa hi a kivial kola chun moment of inertia chu pita point mass khara mala chun. So moment of inertia I is what m r square na mk square in this case. So the radius is k, so you'll have mk square ale hechela hi piam without changing the object's moment of inertia ti chula na atila helai moment of inertia to helai moment of inertia value pa ke ba ngai cho ke ba ngai ding ala chun. Suppose chi pa hi example chi pa solid sphere ti te na chi pe 2 by 5 mr square cho na chi khutile he chi mk square pa jong hi 2 by 5 mr square ma hi ngai cho. Okay, so that means I can equate them. So 2 by 5 mr square. Okay, so from here I can find out the value of k. So here this k is what you call radius of gyration. Sichu ta simple ta he thading ana kan say then apoi mo chu ka say banga chopoi mo chu how to find radius of gyration. Okay, so that is very important. Step number 1 so biham about the given axis khalong ki pi cho find the radius of gyration of this object about this axis na axis ong ki pi ala chun. So about the given axis you have to find out the moment of inertia. First step heji about kipi na axis acho moment of inertia na hol masat penu na masat pena jo abana jo biham equate the above moment of inertia achunga moment of inertia na calculate do pau he na. So equate this with mk square. Okay, and then you solve for k chelai k pa he na si k pa he radius of gyration kiti cho je he k pa he na. So we'll do few questions. See, first thing, suppose I have a rod. Okay, here's a rod pa hi mass m length l dio na si he ale question chu piham find the radius of gyration of this rod about this axis ka dio axis khari apya me na chala hi axis ab dio ta khutile ab axis aya ki rotate ala chun radius of gyration holding chu step number 1 chu piham about the given axis you find out the moment of inertia of the rigid body. Okay, chelai rigid body hi rod chula na about ab hi moment of inertia chu za ta chi. So m l square divided by 3. Yeah, so you have to remember. Okay, rod hi chelai he na chelai he, so this will be m l square by 3. So it hold di ha helai ka he chula if I draw one axis here, so given atang helai axis to given hi na about the center of mass achu axis kan draw wal chun he parallel pa chu man de jo axis theorem pa chu. So here this is ml square divided by 12. Okay, so what is d? So d is l by 2. So you apply ICOM plus md square, right? Okay, direct ana hechela hi moment of inertia of a rod about the end point. So this is m L square divided by 3 hi chong him L chi ta o ale tu cho moment of inertia hi ta na about the n a cho about a b a hi to moment of inertia he zo wa he na hi chi pa hi mk square to equate direct in bol chon so ml square by 3 is equals to mk square so gets cancelled out so what is k square root both side chon so k will be equals to L divided by root 3 so this is your radius of gyration okay na moment of inertia na hold masat diu theorem te ni chu mangcha na moment of inertia na hold masat pen diu aban le chi moment of inertia chu mk square to equate na bol diu equate na bol zo wa chu square root both side la diu na k na hold diu ki sizing chu okay so now let's apply first question the radius of gyration of thin uniform disk ke picho je about an axis passing through its center and normal to the plane to the radius of gyration of a disk about its diameter. Batang, chisa ka sai moment of inertia of a disk about lecture masai bolo chuna. He chosen by heart so you have to remember those things. Hitai disk hat about this axis, okay? About this axis. Hi zata bolwa cho. So here what is I? I is mr square divided by 2 chula na ji disk hiale. Okay, so this is disk. This mama chu about the diameter chu is that if I have a disk like this, it's a center jana I want to axis chu ta hem da chu. Okay, so this is the top view na. Ati le chila hi about the diameter ahe na. I chu jata mr square divided by 4 chula na. Last video also. So now I have seen I have both the moment of inertia. I have to find out the radius of gyration. Atila chepa hi mr square divided by 2 pa hi equals to m k1 to k1 square na masapa chu k1 ani na pa chu k2 tilo hen so mr square divided by 4 is equals to m k2 square question jun k1 to k2 chu ratio whole ven chu atila chala hi gets cancelled out so I will have here k1 is what r by root 2 okay chita banga chu vai nga jong as nga jong hi both side cancel chun k2 chu ring bot ha k2 is equals to r divided by 2 ji jo 2 square is 4 chala na 4 root 4 chu 2 okay atila cha k1 to k2 umta na ratio of k1 is to k2 ratio of radius of gyration ati cho chala here so divide k1 and k2 so k1 by k2 is how much so r by 2 divided by r by 2 okay r by root 2 divided by r by 2 chila hi r by root 2 chung kum na ding anu ya jong hi r khanoma 2 pa ho chunga chi to ding na r cancel out root 2 gets cancel out I have root 2 divided by 1 okay answer should be root 2 is to 1 okay banana next question ratio of radius of gyration of solid sphere ke piche to hai solid sphere about its own axis to that of thin hollow sphere about its axis okay so solid sphere masapa hi solid tiu na je solid sphere ani na pa hi hollow tiu te chi hi hollow sphere okay about its own axis solid achu pita I chu 2 by 5 mr square na hollow achu pitam I chu 2 by 3 mr squared okay so here I have to find out again radius of gyration okay let's say that for the first one it is k1 for the second one it is k2 solid sphere pa hi k1 hollow sphere pa hi k2 na so I have to equate the moment of inertia about the given axis equals to mk square okay about its own axis as chu pa hi chu ji so you have to find out the moment of inertia about the given axis na question chun p ham chi axis is a p chu he chi axis a p na he moment of inertia na hold na so these are direct formula okay direct results chita banga chu gets cancel out k1 chu piong hindiam so k1 chu so root over 2 by 5 na ji chu root 2 divided by root 5 into r okay chita banga abana chu hollow pa jong bol chun 2 by 3 mr square is equals to mk2 squared gets out k2 chu zat ham so root 2 divided by root 3 into r na square root le chun both side to chu ratio do ja chu k1 by k2 hold le chun biung pot do di ham so k1 divided by k2 equals to root 2 into r divided by root 5 so divided by root 2 into r by root 3 so root 3 khuchi do ding root 5 hong kum so ding r gets cancelled out root 2 gets cancelled out so answer is what root 3 is to root 5 okay so that is the answer okay abana to the radius of gyration of a solid sphere of batang hichilai question is solved for here but bona he need exam question ngan so they are asking this question every year so 22 23 24 okay let's see next question the radius of gyration of a solid sphere okay solid sphere is given of mass kipi na chala here is 5m hichi 5m pa he pi ha che pa he k value cho radius of gyration kipi cho question a he so the radius of the sphere is given as 5x divided by root 7 so here the radius is given as 5x divided by root 7 then the value of x is question ake pi value chun chalai sphere cho chi sphere cho pen his sphere is about this axis okay you have to find out the radius of gyration let's say about this tangential axis I direct formula na we have to apply the theorem and then find it ourselves okay to chu ep theorem man ha so here we have to use the parallel theorem na about the moment center of mass I have to draw an axis okay axis khat law na chala he chi ICOM passing through the center of mass chi solid sphere ke pi chula na chu bi ham 2 by 5 mr squared okay ale d chu pi ham d chu distance between the two axes so this is d okay chi za ne ha chi radius r na chi r chula radius okay atile given axis xy a moment of inertia za de ham so ICOM plus md squared formula cho okay ICOM to PM 2 by 5 mr square plus m into d to PM r okay so d square na so therefore you'll have 7 mr square divided by 5 I tacho about the tangential axis na to hin pa mk square to equal bolchun so mk square so mass gets cancelled out okay so 7 by 5 into r so pk ta chila r ke pi pa he chila r khial hin khoi lo chun okay so what will you have r2 so 5 are 25 into x square so divided by root 7 square to 7 na equals to k square okay so here you can cancel some values 7 cancel out 5 are 25 right what else do you have k jong chu ke pi jole k value chu bia k chu 5 ke pi le chun chipa hi 5 square chu 25 na che he so I have here 5x squared is equals to 25 so 5 are 25 x squared to 5 na atile x chu pi de ha so root 5 okay answer chu pi ham root 5 moving on na radius of gyration question hoy velo chun radius of gyration holna ding asong hi moment of inertia holdan het ngai chula na aji chu moment of inertia ne na holdo thei wala chun chipen chu mk squared to equate wala chun chila k chu radius of gyration jing cha so therefore finding moment of inertia is the key okay important abana hi cavity problem dang center of mass ana cavity problem in solve chula chita banga so moment of inertia jong he na solve the method ki bang chat cha see suppose I have say a disk na ita he disk khalom ja chipen he chila this hi batang chila hi moment of inertia chupita at the center chu mr square here chula na chipen he so this is mr square okay about this axis ala to hi chila ku na he na suppose I remove some part of this so some cavity here okay so this part is radius what r by 2 japan here so if this is r right so r by 2 is removed so after you remove at the same axis na hichalai same axis mama hi ahung ke paya lason moment of inertia cho itabang hidam. So what will be the new moment of inertia, okay, after the cavity has been created? So that is the type of questions asked na. Chita ta hichi solve dan chi tin bol ta center of mass cho masa pena cho original mass ko na ko negative mass khat e iha be ji chula na jala hi. So this is positive mass plus sigma chipen hi negative mass minus sigma. Example cho hichi hi minus 5 kg divde na chipen hi plus 10 kg divde khutile chiteni gom le chun pi ha 10 minus 5 cho, so this will be 5 kg. Okay, negative mass concept pa na ata ta chu negative mass ke ti hi lo cho chi question solve na cho technique na so trick to bang chipen hi heje pa hi cavity pa hi, so we are taking negative mass bana che pa hi original mass na original disk is a original disk apa na cho che pa hi na la do di ne cho. Okay, you have to remove this and so here you will have m1 na chala hi m2 to cho betang chala hi axis of rotation chala hi jana khotile alin pa dinga axis of rotation cho lai ta hi na lai cho eba neo pa dinga hi axis of rotation cho lai ha aning pa hi, so now it is here. Okay, cha cho hechi hi chala jong hi moment of inertia of this small disk about this axis. Hechala axis ajong hi hold do na but a moment of inertia about of this about this axis, right? So about an I net cho bita I net cho hechi pa moment of inertia alin pa hi I1 tutin ania pa hi I2 tile na, so I1 plus I2. Okay, right, so that will be the moment of inertia. So let's solve question. Masa pena cho a uniform circular disk of radius r rotating about an axis perpendicular to the plane and passing through the center. Ati lechu hilahi ke saine cho. Okay, exactly in the middle. A circular part r by 2 is removed from the original disk as shown in the figure. Find the moment of inertia of the remaining part of the original disk about the given axis. Okay, chichu kasai banga cho chipa hi okay, original disk time so na this is complete disk. Okay, as you complete disk akona here, so you have to subtract small part of disk. Okay, heji alin ba heza radius to r na anyo pa here radius is ham, so this will be r by 2. Okay, chilai para chilai hi, so this is r by 2. Okay, small heji disk chuna, so small disk r by 2 is removed from the original disk. Ale original disk butang axis of rotation pai holai ha. Original disk value chun, so it lies exactly in the center na axis of rotation cho. Ai wanga niyo pa dinga axis of rotation cho holai ha. So it is at the edge. Okay, ninga ko na. So here negative mass in la phala chun m1 m2 hold on ngai chula na. Hechi pa mass is at ha. Suppose let's say the first one is m1. Masa pa chu plus sigma ila dio. Positive mass khatpa chu negative sigma minus sigma na negative mass. So dang sigma chu piha mass per unit area chu na chala he. So therefore mass will be sigma into area. Okay, so sigma into area chu piham pi r square. Okay, abana chu mass m2 pa chu izat ham, so sigma into pi r square divided by 4. R by 2 whole square, so r square by 4 na chala he. Until m1 m2 dantin m1 m2 mala chon chiteni ani ni na disk cho ani ni na disk ai ja chu individual moment of inertia to hold out masa pena. So let's say the first one is I1. Okay, about the given axis is I1. Ale ani na ba ko about the given axis is, let's say this is I2. Until I1 khuza diham, so disk about the center perpendicular to the plane chupita mr square by 2 so na so here I will have m1 into r square divided by 2. So this is the moment of inertia. Okay, let's see an problem. M1 to sigma into pi r square, okay, into r square divided by 2 into by 2. That's it here. So here this is what sigma into pi r power 4 divided by 2. I1 taso. So similarly we have to find I2. Okay. I2 to that ham I2 to, so m2 into betang chila here. This pa heavy lesion I2 pa heavy lesion hita he this cho. Tocho ichila he moment of inertia hold on na. Evan chila exercise here chula. So see if I try to look in the side view. to cho axis chu chi hi cho okay chilai axis pa he na chi pa he top view he za nu pa he side view antile parallel axis theory mangle hen alaya hi center of mass hi axis khali draw diu na chala he so this is ICOM is that this also mr square by 2 okay chila radius chu piham so here radius is r by 2 okay so ICOM chu piham m2 into r square divided by r to r by 2 na r by 2 whole square divided by 2 mr square by 2 let's write d is at ham so this is d na so d is equals to r by 2 okay small dispar radius to r by 2 so to a moment of inertia hold to so about the given axis so here I2 is equals to what ICOM plus md square ICOM is so m r square by 4 for 2 are 8 m2 into r square divided by 8 okay plus md square m into d who r by 2 so r by 2 square to mr square divided by 4 okay so how much will you have here so 8 2 so 3 mr square m2 so 1 m2 so m2 r square divided by 8 okay mass m2 negative mass pa so na to so m2 piha m2 chu minus sigma pi r square by 4 so chala hinga put lejun I2 chu jan pot diham so 3 into minus sigma pi r square okay so into r square divided by 4 into 8 nah chi hi zat ham so minus 3 sigma pi r square pi r power 4 divided by 32 chu I2 so I1 to I2 imutaw na to so net chu biham I1 plus I2 so I net chu biham I net is equals to I1 plus I2 I1 chu biham sigma into pi r power 4 by 2 pi r power 4 by 2 minus 3 into sigma pi r power 4 divided by 32 okay so LCM na leuchun 32 na LCM ko so I will have here 32 I will have here 16 so 16 minus 3 chuzat ha so 16 minus 3 is 13 into sigma pi r square okay I will write like this into r square divided by 32 so sigma pi r square so piha m din is a mass na mass to sigma into area okay so here or I can write 13 into m r square divided by 32 I net okay that's new moment of inertia pa na so that is equals to so 13 divided by 32 a method pa he na a process pa he chin da o butang step so pi ha hita he hong gi pi so na chi original this akona chu so negative this kha chu kila do it ne chu so here if I add this negative and plus so it will subtract okay anyway yeah so there's a cavity pa he negative mass akala ding din so minus sigma okay so from there I will find out m1 and m2 sigma chu pi ha so mass divided by area na mass per unit area tin so therefore mass will be equals to sigma into area okay so this is what we write here eh abana che plus sigma che here minus sigma he lechun mass masa pa so positive heading mass no ha pa so negative hong so okay so axis of rotation given axis of rotation chu question chun chila he do chu chi ja chu original mass hading axis of rotation chu chi yong ding he je center la he na anio pa ding he a side chul na ji fetan che anio pa he za je axis of rotation chu a side chu okay on the edge of the disc so you find out the moment of inertia of this one and then you just add them okay that will give you the net moment of inertia okay let's solve one more okay tu chung NEET exam question na a sphere of radius r is cut out okay from a larger solid sphere right radius 2r as shown in the figure hotele radius alin pa hi radius sanam radius 2r okay ania pa hi so r okay so ratio of moment of inertia of a small sphere to the rest part of the sphere remaining part dang a cavity part chun cavity kila do zo remaining of the sphere pa na remaining part chu moment of inertia ten jo ratio do zo chila. See, the difference between this question and the previous question is chila his sphere kipi jo solid sphere na. So this is a 3D rigid body. Okay. Previous question so here is disk kipi chula na. So here we take disk has area. Okay. So the thickness of disk is if this part thickness is negligible here so area box and chula na. So chija chu chila he plus sigma minus sigma ila chu che. Ai wang so sphere hong ke di phala chun he hi pia volume anai da chula na volume anai cho. So here we're going to take plus rho and minus rho. Okay. But the final cavity he pa he tiung ke form ha. So from the original, okay, from the original I have to subtract so the negative mass. Okay. Masapa hi plus rho kala ding din in pa hu negative mass minus rho. Okay. Radius to that ham, so radius to 2r. Khatpa radius hi r. Na. Ale m1 m2 chu pi de ha, so m1 chu batang rho chu pi ham mass per unit volume kiti chu rho chu na. So therefore mass will be rho into volume. Okay. So plus rho into volume chu pi ham 4 by 3 pi r cube sphere aso na. So 4 by 3 pi r cube. Okay. So how much is this? So 4 by 2 cubes to 8 8 4 are 32 divided by 3 into rho pi r cube. Okay. Ale m2 jad ham m2 is equals to same thing minus rho into 4 by 3 pi r cube. Okay. Chichu anyo pa na m2 m1 m2 ma lesson to chu betang axis of rotation chu pi ha. About the y-axis ati cho jala hi about the y-axis here la chun. So this is the axis of rotation. Alin pa ding aso alai hin alai cho jala hi. So here this is the axis of rotation passing through the center of mass. Ai wanga neo pa ding aso hilai ha aning da chuna tangential axis. So the given axis is a tangential axis for the smaller sphere. Okay. That means jala hi parallel axis theorem no nan man ngai diu na jala hi. Okay, so now let's see. Masapena cho due to chipahi moment of inertia so I1 tiutin, he chipahi I2 tiutin na. Ale tun moment of inertia M1 to M2 pa hi holte na. So M1 pa cho I1 batang M1 pa hi vela chun solid sphere so solid sphere hinten axis of rotation hi hola ha. So exactly in the middle point na about the center of mass cho. Ale solid sphere moment of inertia about center of mass so ha 2 by 5 mr square na. So 2 by 5 into m1 into r so ham 2r the whole square. Okay. So 2 by 5 into m1 to 32 divided by 3 rho into pi r cube. Okay. Abana 2r square hu 4r squared. Ham ga solve lechon. For 2r 8 8 2 are 16, 8 3 are 24, 25. 256 by 5 3 are 15. Rho pi r power 5. Chihi I1 na. Ale abana chu smaller sphere pacho cavity pacho na. Chipa cho minga holoto. So I have the smaller sphere radius to r na chihi. Ale axis of rotation chu hilai ham axis of rotation chu chilahi. So about the tangent. Okay, tangent acho na. Ale chilahi bedang tangent na hol na ding acho parallel axis theorem man ngai chu na chilahi. So parallel axis theorem chapita. We have to choose an axis passing through the center of mass and parallel to the given axis. Center of mass passes at ham. So 2 by 5 mr square na. So 2 by 5 m2 into r squared. Chipahi m2 tiu to anya pahi na. So chihi m2 hinding. Bale to cho d jong hol ngai na. So chihi d cho. So distance between the two axes. What is d here? So here d is r. So therefore I2 cho pi ham ICOM plus MD square. ICOM to 2 by 5 M2 into R square plus D to R na. So M2 into R square. Chichu ham 7 M2 into R square divided by 5. m2 value is that so rho into 4 by 3 pi r cube na minus rho into 7 by 5 into minus rho into 4 by 3 pi r cube into r square. Okay, so is that no problem? Say minus 7 4 r 28 by 5 3 r 15 rho into pi r power 5 to I2. Okay, atile to hi remaining part na question answer pp kidonga ratio of the smaller divided by the rest part aticho rest part so net na inet to zanham so inet is equals to I1 plus I2. Okay, chuchu piha I1 to so 256 by 15 rho into pi r power 5. Okay, minus sila isa 28 so divided by 15 rho into pi r power 5. Okay, 26 minus 18 is that so I will have here 8 so 228 divided by 15. Okay, rho into pi r power 5 na chepenchu inet kiti he piha cavity ke la do zo remaining part so na chepa moment of inertia chu inet so jala he. Okay, to hi pp hold so equation number 1 divided by equation number 2. Okay, smaller sphere divided by rest part ati so na je tile zat ne so I2 divided by inet smaller sphere ko minus 28 divided by 15 is into rho pi r power 5 divided by so 228 divided by 15 rho pi r power 5. So this cancel out na ratio was a negative sign so just remove it. Okay, take the magnitude part is that has 15 cancel out so 28 divided by so 228. Okay, let's see cancel him 4 7 are 28 4 5 are 20 4 7 are 28. So finally you have what 7 divided by 57. Okay, so it's option number 1. So tang hechi masangap ko nakizil saw hilawana. So if you are doing for the first time, it is lengthy. Okay, first thing hechi need question jon simen chija jo question khali na nama solve ngayo so they can ask you the similar questions can be repeated na radius hoge khiala jon question chum ki sim thai jo jela hi. Okay, apoi mo chu pi ham tang positive mass allow to negative mass allow ba he na heche pa he thi mongai cho heche center of mass ajong bol da cho na cavity problem a cho. So here the question are required pa he na heti hung por ham tele original apara chu heche pa he na negative pa mass pa na 8 khum wal chun chu subtract to ke pang da chola minus plus minus na. Okay, so I hope you understand. Now you have a continuous rigid body. But rigid body teacher rod ho disc ho ring hoi bolo na abon na rigid body cho e ho chun final result bose direct ai by haro jana jo jo hi cho iti hung kun ham ti tem khat derivation ka bolo ten na jo ji question khale ni solve na jong ki bang ni ja se ti integration bol dan pa he na ji. Okay, so see rod here chuna rod pa ko so I have a rod here. Okay, rod to mass m length alum na atile moment of inertia about this axis. Okay, about this axis aso pita ml square divided by 3 cho na ji ale hechi hi betang e hon result theorem se man vai apply jing na ji. So using integration, how do you solve this? So you have dang hechi continuous body hong ke pial chun na integration bonaring aso pia integration jo pikit na hechi rod pa he na hechi rod pa hi so you have to cut this into small pieces. Okay, hal na ko yu na hal na ko yu bal chun hi cho chun na plus khom diu tin cho you have to add all of them. Okay, so integration means summation na chita bang so here I'm going to take a small segment. Okay, let's say the length of this segment is dx at a distance of x from the axis of rotation. Okay. Atile chi dx pa he value chun na. He chi axis of rotation chi za. Chilai ko na he distance x a he cho. Na chilai mass khat chi pen chu he chi dx sunga mass pa he na chi pen he dm tiu da chi. Okay, so small mass is dm. So here the mass is dm. Okay. Atile he chi pa moment of inertia he na. Ko hol no mal chun ipita formula so. See, this is like a point mass. Okay. Point mass khat chu distance x axis of rotation akona amala chun moment of inertia jo piha m into r square tiu chula na chila hi mx square. Okay. Right? Moment of inertia. Chiju ka manala chun. So here I will have the small moment of inertia. Okay. HG ahena. So due to this, the small moment of inertia is equals to dm into x square. Okay. I chu piha mr square chula na chila hi r chu piham x. Okay. Mass chu piham dm. Integrate both side ka bola la chun. So integration of di to I na. I is equals to integral I dm into x square. Okay. Chi formula tabang ki bang thai chu. Okay. So here dm chu pidha chala hi. Rod pa hi lambda tile na mass per unit length. So lambda. Okay. What is lambda? Mass per unit length. Okay. So lambda chu tang small mass pa hi. So chala ka hai na. So here in depend hi dx is a. So here what is lambda? Lambda is mass divided by dx. Okay, mass per unit length na. So therefore what is dm? So dm is lambda into dx. Okay. Chipa he put leo chun. So therefore I is equals to integral dm hela ho lambda into x ka pudding na into lambda into dx. Okay, into x square. Okay. Integrate bol leo chun. He chi x pi hela chi ha. So it goes from here, that means x equals to 0 to all the way x equals to L. Athung ke achi chula na x so. So dm pa hi aban bana tai kalding kaldo to na so integration so aban bana so addition ki bol na. So here how much is this? Integration from 0 to L. 0 to L. Lambda cho piham mass by L. So x square into dx. Mass by L cho pod wala chun. X square integration jo biham x cube by 3. Na chipen hi from 0 to L. Value limit put le chun jan pod de ha. So ml square ml cube divided by 3 into L. So 1L gets cancelled out. I have square. Chichu ml square divided by 3. Okay. Aki derive dan ta pensiona. So the ahung ko no na pa so na si penso chi cho. So using integration. Okay. ml square by 3, right? Chita bang aso na hebatang rod khat hi rod about center of mass alai ta khoi pita ml square by 12 itu so la na chong. So chong so iting ko no ha. So here I have a rod. Okay, mass m, length l. Atila chun chila hi axis chu chila ka select ala chun to hi chi length hi zat ha chi l by 2 na chi. So here I will take the same thing. Segment kala de na jala small segment length to dx. Okay, from the axis of rotation at distance x. Chipa mass to dm. Na atile lambda cho piha lambda to mass per unit length dx. Okay, this segment akona small segment adinga lambda pa cho. So here the lambda for the small segment is dm by dx. Lambda kiti cho it is same, okay, throughout. A rho adding azong so lambda cho piha rho alom lambda to mass divided by length. Okay. To ajo butang ajo a formula pen so direct mangsin taw pen I equals to integral dm into x square. So mangleo chun zanong pot de han chla hi. So I is equals to integral dm into x square. Chla hi dm so piha lambda into dx na chi. Lambda into dx into x square. Abana limit pa na hula pa hula chi ha. So here limit pa he beta chila hi 0 cho. So chila hi 0 na. Atira chila hi pi de ha chilang hi. So this will be x equals to minus l by 2. Okay. So this will be x equals to plus l by 2. limit to minus L by 2 apana plus L by 2 sanjir. Okay, so from minus L by 2 to L by 2. Okay, atile is that data lambda to mass by L, so pola lado leng ml. So from minus L by 2 to L by 2, x cubed by the x squared dx na chi. Okay, 2 integrate bol leuchun m by L into x squared different integration to x cubed by 3. Okay, he chi hola pa hola chi ham, so minus L by 2 apana L by 2 chan. Okay, so m by L value put leuchun, so 3 zong la do ingate apolanga, so L by 2 cube to L cube divided by 8. Okay, minus pulang minus L cube divided by minus oma bana jo, so minus L by 2 the whole cube. Hitin ji masate khabe L by 2 whole cube. You confuse no ninga chana masa pena chu heji x hela hi L by 2 kaput so sela hi, so I will have L by 2 cube abana chu x hela chu L minus L by 2 kaput na sela hi minus L by 2 cube. Okay, 3 pa hi polang kala ta so sela hi. So here what do you have? M by 3L. Okay, so I will have here L cube divided by 8 minus plus L cube divided by 8. Okay, so L by 8 plus L by 8 to be L by 4. Da. So here I will have M into L cube divided by, so 3, 4 are 12L. Okay, chipa hena solve leuchun, chiteni solve leuchun, so 2L cube divided by 8 is so you'll have L cube by 4. Na, heji 4 to hin, heji 3 pa multiply leuchun 12 from pot leuchun. So 1L, L gets cancelled out. I have square. Finally, you have ML square divided by 12. Ihon here about center of mass moment of inertia pa ko na ML square by 12 pa ko ang po to dan chi hi. Okay, so you get that value by using integration like this. But ang chito bang hearing azong ko this azong ko na abale solid sphere hemisphere ti apon ako integration ki bola hong po dito. Ay banso chala hi integration abona kan bola dito. Abana suppose I have another one ida hi axis so rod mama na I have a rod pa hito hi angle ata ki koiso. So now I have a rod like this. Okay, so rod of mass m length L hichi theta angle ata hi so slanting. Okay, slanting ga ki koi na position acho hita hi ki rotate ta chu ki rotate ala chu moment of inertia pa chu pm hold odina chala hi. Okay, so steps of pm, so masa penso dx hold masa ngai na. So I'll take here dx. Okay, hi so dx distance of is that hi, so chipen hi x na atile to hi integration kiti pa hai na. So now to integrate you so ta him cho na chi along the x cho ai wang to hi x lang hi lo cho rod pa hi velo chun x lang azong umlo y lang azong umlo ta chu component la ngai na chi. Example here dx pa here, now it is at a distance of, so this one is that the pen here. So what is this length? Here pa here x here lechun here opposite side na pen here. So this by this is sine theta, so therefore this is equals to x into sine theta. Okay, just pen here x sine theta. Okay, mass to dm. So dm pa chu x sine theta okay, so something like this. So at a distance of x sine theta, so I have a small mass dm. Okay, at the moment of inertia pm, so small di is equals to, so dm into m into r square na r to pm chila hi x sine theta the whole square. Okay, right, is that hamji? So this is what integrate both side. Okay, I will have I is equals to integration of dm into so x square into sine square theta. Okay, that's like sine theta ung podan hello vala chun like triangle have it so the triangle hai na. So this is theta, so this is x, so let's say this is k. Okay, atila sin theta chu pi ha. So here this is k divided by x na. Ale k chu pi ham k chu x into sin theta. Okay, so this is how I get it na. Atila ipta hi line he dekho chu theta ki pi pa hai na. Chi angle ki pi pa hi chi constant so chi pe angle ki hial lo ri chu. So it will rotate with this angle theta, okay, around the axis na. Atila chilai theta pi constant. So theta constant a hilachun sin square theta is constant na. So that means, see, from where to where integration hula pala hula integrate ha. Chilai dm pi he pe ha. So dm so lambda into dx chula na so evolve bacho. So here what is the lambda here? So lambda is mass divided by length. So therefore dm is what? Lambda into dx. Chipen put kilauchun. Lambda into dx into x square sin square theta. Okay. Abana lambda cho piha mass by length mama hita jong kizit hecho overall lambda jo na. Chija cho chila he mass by l cho lado ingating. So sin square theta jong constant na kala ding. So I have x square into dx. So from 0 to l. X pa he 0 to l achi cho. Okay. So therefore what do you have here? M by l. So sin square theta into x cube by 3. So from 0 to l. Value he put lechun finally moment of inertia cho ha. So m by l into so l cube divided by 3 into sin square theta. Okay, l khat to l khat cancel lechun l square na. So therefore you have I is equals to what? ml square by 3 sin square theta. Okay. Hiji pen hi result ajong na baya te chu chi. Exam acho batang rho khat hong ki pi ai ta hi rho khat ma angle chilai 45 degree hong ki pi ala chun direct achi formula na apply theo na. ml square by 3 sin square theta. Okay. Hatile rho da he chen chu remember okay. Hiji pa jong hina result ta ba na baya theo chu. Okay. Right ba na chu problem khat maintain a rod of linear length, linear mass density lambda, length L is bent to form a ring of radius R. Moment of inertia. See, I have a rod. Okay. Hita he rod khalam cho. Chuchu mass M, mass lambda ki pi na chipen here. So this is lambda. So length to L na chi. Ale chapa hi ki bent in tin ring khat ki form jo chala hi. So now it is bent to form a ring. Okay. Radius is a ring pa radius here. So how can you write the radius of this one? But ring pa rod pa length L so na japan here. Chipa he ring formanan koiwa chun he circumference pa jong hi L hi ngai cho. Okay. So that means circumference of circle to 2 pi r equals to L. So r is equals to what? L divided by 2 pi. Okay, radius so na. The next part chu moment of inertia of the ring about its diameter. So about this diameter is what? But so ring kharahung mana about diameter hilchun I chu pita I chu mr square divided by 2. So here chulana jela he. Okay, then here you can just put here I chu piha I chu m r square by 2 r chu piham L by 2 pi. Okay, the whole square divided by 2. Right? About lambda chu piham mass per unit length. Okay, so therefore mass is what? Lambda into L. Okay, so I can put that value here, lambda into L square divided by, so 2 are 4, 2 are 8 pi square. Okay, is that lambda into L cube divided by 8 pi square. Answer to option 1. Okay, bana chu ring. Ring ong ke pipala chun ipita ring I here ho chu. So if I have a ring like this, okay. Chi radius hi r hi le chun. Moment of inertia about this chi axis pa hi pita. Chu mr square iti chuna jela hi. Ala chun, see if I have another semicircular ring like this, okay. Semicircular ring, so say mass is m. Okay, jela hi mass m cho. Mass m radius r hi le chun. Above this axis moment of inertia chu pi de ha. So again you'll have mr square ki bang cho. Okay. Similarly, any segment, okay, any section, suppose I have a ring like this. Nah. Okay, so some angle is given theta. Theta angle kipia, so they ask you moment of inertia about this axis. Okay, suppose if the mass of this is m, then moment of inertia about this is also again mr squared. Okay, ring acho na, ring acho it abang section ki ka dohan lang na. Hizong le moment of inertia pencho mr squared hi hising nicho. Okay, so the one point you have to know is to a ring pa hai na. To ring pa hi, so if this ring is cut, okay, like this. Mass ho hai na to hi mass m hi talo jo chala hi section pa hai na chi. So this is m by 4. Okay, this is m by 4. This is m by 4. Tang liya ke hop khana sun mass as quarter khat jo mass m by 4 ta chala na chala hi. So chita bang hi question hong ke do ring apa ki kal ha hai atial chun na. So if you have a segment like this, so suppose you have a section, okay, chipen hi angle jo 90 na ji 90 here chun chipam chipen mass hi ha m by 4 ta cho. So it's the center moment of inertia ko holding al chun a formula is mr square chola na ji e ba chala m hi ha m by 4 cho. So here the moment of inertia will be m by 4 into again r square. So mr square divided by 4. Okay. But angle random angle ka ongki pia chun suppose hechi ring ko na he na. So from a ring, so it is cut out, some angle is cut out. Okay, so let's say theta atile hechi aki cut out pa mass he tin holo ha. So how do you find? So here let's say this mass na, so m dash hechi pa he, so total mass apala ho theta by 2 pi. Okay, this is how you found it. Formula pension na aji chu veta chalai jong hi vela chun chi 90 degree cho 90 degree cho pi by 2 na ale hin che formula apply la chun m dash che pa hi m dash cho m dash cho pe ha, so m into 90 degree cho pi by 2 divided by 2 pi, so this is what m by 4. Okay, any angle kepi jong la na chala hi a ho la chu chu cho. Suppose you're given here in place of theta 30 ki pi cho na angle 30 here chun he 30 ka asunga mass pa chu de ha ji. So here I will have m into, so 32 pi by 6 divided by 2 pi. Okay, until mass to m by 6 to r 12. Okay, the mass of the segment na aji mass ne here vala chun formula to mr square hising cho. Okay, so it is always mr square. Mass pa se ke khial thai cho to so heji pompi hi na mass m hi la chun ji so mr square he sa ai va so m by 4 he chun jala m by 4 na put you r square. Okay, chala so ring aso na, you have to remember that one. Okay, it is always mr square if the mass of this is m. Okay, if this is m, it is always mr square. To so you have one question from a circular ring. Okay, mass m ita hi circular ring um na jala hi chilai ko na hi mass chu m hi za radius chu r na chi radius hi r. So an arc is removed at 90 degree sector. Arc corresponding to 90 degree sector is quarter ka dine cho. So here this arc. Okay, so this is 90. Chalai ka hai na ji. Ale chalai ka mass 18 holo diu ham. So total mass into theta divided by 2 pi. Na theta so biham 92 pi by 2. Okay, so this is pi by 2. So pi by 2 divided by 2 pi. Until the mass should become m by 4. Okay, now I got the mass. The moment of inertia of the remaining part of the ring about the axis passing through the center of the ring, chila axis hai na, and perpendicular to the plane is k times of mr square. K should become. To I amon do pen chu chila ya he section pa hi hilau na, he pa hi hilau then remaining parts of those. Until remaining part mass is at the ham, so m double dash. Khapa m by 4 here chun remaining chu m minus m by 4 chu 3m by 4 na je chu mass ta chula. Okay, so same thing, mass m here chun moment of inertia chu mr square diu chula na chala hi. So therefore the moment of inertia of the remaining will be mr square. So that means m dash r square. So m dash should become 3m by 4 into r squared. So that means 3 by 4 times of mr squared. Answer to piham, answer to 3 by 4. Okay, so remember ring haokipiit alachun na. Ring haokipiit alachun. So batang any shape hichi semicircular ring jong hi moment of inertia about this axis is mr squared. Okay, section khajong so moment of inertia to mr squared. Okay, hichi total mass hichi pa mass m hi lachun na. Ai wanga cho full ring akon haoki kal la phala chun hichi pa m hi ji dalo so. So it may be m by 2, okay, maybe m by 4 na. Hichi m by 4 pa hichi lai na puru like sizing. Okay, so mr square. So you have mr square, you put the value of m, you'll get the answer. Okay, now you have disk. Disk zong kibang. So I have a disk. Ita disk so na je radius r, okay, mass m. Hijela hi ipita moment of inertia cho. So mr square divided by 2 use na je. So similarly, if you have a semicircular disk, okay, about this axis, so mass to m here, radius to r hilachun. So again, moment of inertia is mr square divided by 2. Okay, so any section you have, that's here. Here mass m here hilachun, depending theta. Okay, any angle you take theta, mass m radius r hilachun. About this axis, moment of inertia is mr square divided by 2. Okay, right? This akona hena. So if the mass of this disk is m, radius is r, so from here if it is removed, remove for example, so here this 90 degree is removed. Okay, so remove part pahi a mass is at yaha. So what is m dash here? Same thing as I bolta bang so m into theta divided by 2 pi. Okay, chuchupiha m into 90 degree to pi by 2 divided by 2 pi. Chuchu m by 4. Okay, atile chun question jong gidong so chi hichi sector section pa hena hichi pa moment of inertia hizat yaha. So you're given like this. Okay, so now what is the moment of inertia of this part about this axis? So again it is mr square by 2, but now in place of m you have m dash. Okay, m dash r square divided by 2. M dash value to put m by 4. Okay, mr square divided by 4 to r 8. This is the moment of inertia. Yeah. Okay, last point. Previous video as kan koi lo na japan hi to hi chomlia koi momong chu chala hi. So additionally I will give you 3 more rigid bodies moment of inertia na by hadeu na. Mas happen to triangular plate about the base. Okay, about the base, the moment of inertia is mh square by 6. H should be height. Okay, mh square by 6. Upon a solid cone, solid cone to okay, so here this is a opposite. Hijipahi hollow cone. Okay, so for a hollow cone you have mr square by 2. Okay, Japan hollow cone na je. Abana jo solid cone aso na. So for solid cone it is 3 mr square by 10. Solid cone. Okay. Moment of inertia na by hadyo. So triangular plate acho about the base to mh square by 6 h height na. Abana so hollow cone to mr square by 2. Abana solid cone pa to 3 mr square by 10. Okay. So nitang to moment of inertia. Okay. So whatever I think is important, question previous question ako na kavera na. Question kitong hako na so concept EPP pa mo am EPP bol ngai ham de cho moment of inertia bona I bol ta cho chila him video ni a na. So I hope you understand akira para ko rotational chapter thildang ho na torque de ho equilibrium question ho na he cho solve ta cho.